Hello, my dears. How are you? I'm very fine. I'm called Asnaga Hailo from Ethiopia. I'm doing my job here at our university as a physics lecturer. I'm requested to do this problem. Please, can we tackle together? Thank you. Look, my dears, what he says. A downward forces of 45 Newton and then 50 Newton respectively are required to keep a plastic block totally immersed in water and then oil. If the volume of the block is 8,000 cubic centimeter, the density of the oil is. So we requested the value of the density of the oil. Great. Now solution. And then please, as what we have discussed earlier, in our earlier problem, you have to remember what we did in our earlier problem and then what we narrated about the Archimedes principle. Great. If so, look, my dears, let it be. This is the water, okay? This is the water. And then let it be. This is what you call it, an oil. Let it be, this is oil. Very good. And then the same box, and then the same plastic block within the water and then within the oil respectively. And then this block, if totally immersed within the water as well as within the oil, with such a volume, if so, we request the density of what you call it, the oil. Let it be this is water. Let it be this is water. Let it be this is oil. We request you to find the density of oil. Okay, let it be this is a box. And then this is also the box within the oil. Great. To be completely submerged within the water, a 45 Newton force should apply upon the box. And then look, it should be downward. And then the weight of the box also downward. How many forces do you see which is downward? That is mg as well. The applied force, which is known as 45 Newton. What else? There should be another force whose name is known as upthrust or force of buoyancy. Force of buoyancy. Let it be force of buoyancy because of or within the water. Great. If so, look, to be this block at this position, the net force should be 0. That means, look, negative 45 Newton and then negative mg. Why 4? Because they are downward forces. And then plus force of buoyancy within the water. That is the density of the water. The volume of the displaced water times g. But don't forget, force of buoyancy is equivalent with the weight of the water. I mean the weight of the displaced liquid in general. Let it be this is 0. So the same thing was true here. mg is downward. And then is 15 Newton force required to displace such a volume of oil from the system. And then the third force is known as force of buoyancy within the oil. 1.5 Newton, and then neg of mg plus density of the oil, volume of the displaced of the oil times g should be 0. That's good. Now, my dears, you have to take this technique. Just sum it, or sum up, or first multiply by neg of 1 this equation, and then it becomes, okay, neg of 1 times neg of 1.5 positive 15, neg of 45 Newton plus positive 15, it becomes negative 30 Newton. Neg of 1 times neg of mg becomes positive mg, and then sum up, it becomes 0, and then it becomes the density of the water, the volume of the displaced water times g minus the density of the oil, the volume of the displaced oil times g, which is equal to 0. Now what we have to do, just take this to the left side, and then it becomes, look my dears, and then it becomes, take to the right side, I mean to the left side, it becomes density of the oil, volume of the displaced oil times g is equal to 30 Newton, simply density of the water, volume of the displaced water times g, and then minus 30 Newton. Correct. Now density of the oil becomes density of the water, volume of the displaced water times g minus 30 Newton, the whole over volume of the displaced oil times g. And then don't forget the volume of the displaced oil and then the volume of the displaced water is the same with the volume of the plastic block, that is 8,000 cubic centimeters. Now density of the water becomes, density of the oil becomes density of the water 1,000 kilogram per cubic meter times 8,000, am I right? Times 10 to the power of negative 6 cubic meter times 10 to the power of 1 meter per square of second minus 30 Newton. And then the whole over volume of the displaced water 8,000 times 10 to the power of negative 6 cubic meter times 10 meter per square of second. Very good. Look here, my dears. This means 8 times 10 to the power of 3 times 10 to the power of negative 6, and then it becomes 8 times 10 to the power of negative 3, and then 8 times 10 to the power of negative 3 times 10 to the power of 1, 8 times 10 to the power of negative 2, and then it becomes simply, while we multiply 8 times 10 to the power of negative 6, negative 2 within 1,000, it becomes, density of the oil becomes 80 minus 30 kilogram cubic centimeter kilogram times meter per square of second, which is known as Newton. Okay, Newton. And then don't forget this is cubic meter by cubic meter cancel, and then it becomes 18 minus 13 Newton over, this becomes 8 times, simply 8 times 10 to the power of negative 3, negative 3 times 10 to the power of 1, it becomes 8 times 10 to the power of negative 2. Simply 8 times 10 to the power of 2, and then its unit becomes, kilogram per, this becomes 50 over 50 over 8. 50 over 8. Look, my dears. Can we do with the other page, please? Can we move to other page, please? Now look, my dears. Now the density of oil becomes 18 minus 13 times 100, the whole over 8, and then kilogram per cubic meter. This becomes density of the oil becomes 50 times 100 over 8 means 4 times 2, and then kilogram per cubic meter. By 4 1 by 4 25, by 2 1 by 2 25, and then density of oil becomes 25 times 25 kilogram per cubic meter. This becomes 625 kilogram per cubic meter. We did it. This is a great job. Thank you for watching. Please subscribe my channel. Bye bye.